3. So 9 is 3 squared, and then x plus 1. 81 is 3 to the 4, x minus 3. 27 is 3 to the 3. So 1 over 27 is 3 to the negative 3. X minus 2. Then we do some distributing. So we get 3 to the 2x plus 2 over 3 to the 4x minus 12 equals 3 to the negative 3x plus 6. Now I can't just drop off the bases right now, because the only way I can drop off the bases is if I have base to exponent equals base to an exponent. So I have to first put this side together, the left-hand side. When I divide the same base, what do I do with the exponents? Subtract. So I'm going to get 3, and then 2x minus 4x is negative 2x. 2 minus a minus 12 is plus 14. And then it equals 3 to the negative 3x plus 6. Now we have the same base. And once we have the same base, we can set the exponents equal, right? Base to exponent equals base to exponent. Then I can drop the bases off and say that negative 2x plus 14 must equal negative 3x plus 6. I'm going to add 3x. And I get x plus 14 equals 6. Subtract 14. X equals negative 8. And remember, we could y1, y2 this. And we should go second trace 5, enter, enter, enter. We get the same answer. Number 2 is a word problem. I told you you're going to have one of each word problem type. If there's 3 word problem types, you're going to have one of each on your test. This one is the doubling word problem. So it says 10 bacteria cells. So that's I. Are placed in a petri dish. They double. So R is 2. They double every 20 minutes. Is that the period or the time? Is it the P or the T? It's the period. Every 20 minutes, every 20 minutes, every 20 minutes it's doubling. So that's the P. How long will it take for there to be 2,000? So they gave us final, and they're looking for T. So we get final, which is 2,000, equals initial, which is 10, bracket 2 to the T over 20. And what's the first thing I have to do? What's the first thing I have to do? Divide the 10 over. So I get 200 equals 2 to the T divided by 20. And then I could y1, y2 this. I could, but now I can actually do what? Solve it by what? Convert it to a log. If I want the exponent to drop down, I convert to a log. So I go log base 2, because the base of my exponent becomes base of my log. What's with it doesn't stay with it. So it's 200, and it always equals the exponent, which is T over 20. And then how do I get 20 by itself, or T by itself? I multiply by 20. And what do you get? If you're typing into your calculator for the old ones, you're going to go log base 200 divided by log base 2. Or you can use the log base button. So we're going to go 20 log base 2 of 200, which is 153 minutes. All right. We have to convert to exponential form. How many pieces can we have to convert to exponential? 3. How many do we have? 3. So we can convert right to exponential. The base of my log becomes base of my exponent, which means I need an exponent. What's my exponent? 7, and it equals x plus 2. It didn't ask me to solve, it just asked me to convert. I'm done. Number 4, I have to convert to a log. What do I have to do first? Divide the 3 over, because right now I have 4 pieces of information and I can only have 3. So I divide the 3 over, and I get 5 to the 3x equals 9. And then I convert to a log, because that's the only way I can get the exponent popped down. So I go log base 5. Now just so you know, this is a subscript, right? It's log, lower number 5, and then the 9 goes beside it at the exact same height as log. Like you go log 9 and put a little subscript, right? And then it equals 3x, and then we're done, because I just wanted you to convert it. I didn't want you to solve it. Number 5, I actually want you to solve. So what am I going to have to do first? I have an initial and I have a final. Divide it over. So I get 2 equals 6 to the 2x plus 1. Now I have 3 pieces of information and I have 1 exponent. So what can I do? Convert it to a log. So I get log base what? 6 of 2 equals 2x plus 1. Then what do I have to do? Subtract 1. Now make sure you close that bracket on the 2 or it's going to subtract the 1 from it. I have to go log base 6 of 2, enter, subtract 1, enter, and then I'm going to divide by 2. Now remember, when these are solves, I could y1, y2 this, or y1, y2 that, and get answers too to check it. So, if I go log base 6 of 2 minus 1 divided by 2, I get negative 0.31. And if I y1, y2 that question, I get negative 0.31. My last one, what do I have to do first? Divide the 2 over. We're going to learn that we can actually bring it up as an exponent as well after today, but for now we're going to divide the 2 over because it works out evenly. I get log base 6 of 3x plus 4 equals 2. Okay, what am I going to do after this? Exponential. So I'm going to get 6 to the 2 equals 3x plus 4. 6 squared is 36, which equals 3x plus 4. Then I'm going to subtract 4. And I have 32 equals 3x. Divide by 3. X equals or just 32 over 3, right? So unless they want you to round it, you're going to say 32 over 3. Okay, that's it. We're going to go to the notes that's in front of you. So on your formula sheet, there are laws of logarithms that you're never going to look at. They're on there, but you're going to learn the rules so much that you aren't going to look there for them anyways, because they're written very, I guess, separately, and we're going to use them together as a rule. So the first rule is multiplication. Once my smart board decides to join us. Basically, it's this one up here. It says log AM plus log AM plus log AN can be written as log AM times N. So basically, so we have log A, M times N can be written out as plus, okay? Or if you have 2 logs of the same base added, you can write them as multiplied. Same rule goes here. If you have them subtracted, you can write them as division. And the third rule we're going to learn is the exponent, and this only works with a log. Your exponent, if you have an exponent on a log, can drop down in front. So this can actually drop itself in front. So we're going to go through and use some of these rules. So here it says, write each expression in terms of an individual logarithm. So we're going to write them as individual logs. This is one whole log. We want to write them as in terms of extra x, y, and z individual logs. So this is the key thing you need to know. If you have multiplication or division of a log, something beside a log, you can write that out as an addition or subtraction of a log. Okay? So if it's the easiest way to remember this is if your variable's in the numerator, you put a +1 in front, you add it. If your variable's in the denominator, you put a -1. Now, the rules over there state it, that if it's division, you'd subtract it. If it's multiplication, you'd add it. Correct? I'm like, thank you. Don't really care. I'm not going to go look at those rules. What I'm going to say to you is, if the variable's in the numerator, you're going to put a plus 1 in front of the log. If the variable's in the denominator, you're going to put a minus 1. So what the heck does that mean? Well, let's go through and let's look. So we have log base 5 xy over z. So we're going to, the x and the y are both in the numerator, correct? So we can write them with plus 1s. So we can go plus 1. What does a plus 1 do in front of a log? Nothing. I'm just doing this for effect. So plus 1 log base 5 of x. And you put the x in brackets always. Whatever's beside your log, put in brackets. Okay? Now the y is also up there, correct? So what can I put in front of it? A plus 1. Do I really need to write the 1? No, I'm doing it for effect. Log base 5 of y. The z is in the denominator. So what can I do now? Yeah, minus 1. Log base 5 of z. So really, that isn't incorrect what we just wrote. This actually is equivalent to this. That's why I put an equal sign, because these are expressions, not equations. So this equals this. I put an equal sign down. And it's not wrong, but they're not going to write it that way. They won't write the plus 1 in front of the very first term. They'll just go log base 5 of x plus log base 5 of y minus log base 5 of z. That's it. That is literally the rule. So you can take one single log with multiplications and divisions beside it and write it out as a whole bunch of logs with addition and subtractions. That's really the rule. That's all it really is stating. Okay? So we're going to look at b. b just has one x beside it, but it's a cubed x. Cube root of x. So we can write it like it is just sitting, log base 7 cube root of x, but we're going to go back to grade 10. And if I gave you x to the half in grade 10, remember I was talking to you this, I told you guys this before. This 2 actually comes in front as the index on the root, correct? And the exponent would just stay underneath. So this is the same as writing the square root of x to the 1. These are the same. Do I need to write the 2 if it's a 2? No. Any other number? Yes. Okay? So if they have the cube root of x, x is to the 1 if it doesn't have an exponent, correct? So what is that the same as for a fractional, a rational exponent? X to the 1/3. We agree? So I can just write this as log base 7 x to the 1/3. Now we're not separating it out, right? So it's not using the rules of before. It's not using the rules I used before. It's using this rule here. So this is correct, and there's nothing wrong with that. It just might not be your answer. What they might do, and this only works if you have a single log and the variable is at the top, is you can take that variable of 1/3 and you can drop it in front. So we can write this as 1/3 log base 7 of x. And I'm going to prove to you that this is not something that's wrong. Birds are calling me. It's a great day to be a bird. Okay, so I'm going to prove to you that this is true. So if I go and do this, paying attention. So say I go math log base, and I say 7, and then I say, 3 squared. I get an answer, correct? Now, if the rule I said is true, what could I do with that 2? When there's a log, what could I do with the 2? I could take the 2 and I could drop it in front. So I could go 2 log 7 of 3. It's the exact same answer. That's why the rule works. Do you see that? So the exponent can stay up, or it can drop in front. And there's situations where we're going to actually want to move it. But it's also sometimes just to match the answer they have in the multiple choice. Okay. I don't know what's going on with you guys, but
Austin. Whatever it was.
can't.
You can continue.
So we have, oh, thank you. So, how can we rewrite 1 over x squared? Well, how else can we write it? X to the what? Negative 2. So we could rewrite this it worked. It's still not working.
Yeah, why don't you go put the pencil shavings on the board? I know it was.
Just gonna say tick, I guess.
That's a big writing. She knows.
Thanks.
You're welcome.
This is my forehead. Bullseye. That's how tall I am. I thought I was taller. Interesting. Okay, so how else could I rewrite that? I thought if I let it go. What is, like, we're not going to be able to scroll. This is going to be real ugly real soon.
Maybe we should just stop class. That's a good
Yeah. Okay, what do we do with this exponent? We could take the exponent and we could do what with it? You could drop it in front. So you could write this as negative 2 log base 6 of x.
What else did you put in there that I cannot see at the moment?
All right. D. How could I write D? What could I do with D? Yeah, I could do what I did with the first one. So I could go log base. What is the base if there's no base? 10. Bless you. So I could go log base 10 of x to the 3. And then what do I do with the two bottom ones? Minus them. Minus, guys, you gotta stop. Minus log base 10 of y. Minus log base 10 of root z. What's root z the same as? Z to the what? This would be a z, right? To the 1. It has a 2 here. So what would it be? Z to the 1 over 2. Now, they might not actually have that as the answer. What they might do is actually take all the exponents on each of those separate logs and drop it to the front. So they might go one more step. They might go 3 log x. Because do they have to write the base 10? No. Minus log y. Minus 1/2 log z. Luckily, this says, your turn. Go. Okay, so we have log base 6 of x over y. So this is what's beside it. So we're going to get log base 6 of x minus log base 6 of y. And that's, make sure you have equal signs running down the left-hand side because these are expressions that are equal to each other. There's nothing more I can do. I am done. There's no exponents to put in front. They all are to the 1. This one, before I go and expand it, I can go log base 3 of 9 over x to the, oh, that's the cube. Yeah. The cube root of x squared, so it's x to the 2/3. So when I expand this out, I'm going to get log base 3 of 9. I could put a plus 1 in front of the log. It would be fine. And then because it's in the denominator, I'm going to go minus log base 3 of x to the 2/3. Log base 3 of 9 is actually 2. And they're going to expect you to turn that to a number. So your calculator, you go log base 3 of 9 and it's telling you it's 2. What your calculator is doing every single time it's doing a log base just so you know what it's actually doing, is it's saying this base to what exponent is 9? So 3 to what exponent is 9? 2. So the answer to this is actually 2. So sometimes if I got like log base 2 and then a 9, I can't actually directly give you an answer, but I do know this is 3 point something. Because 2 to what power is 9? Well, 2 to the 3 is 8. 2 to the 4 is 16. So I know it's a little more than 2 to the 3, right? So it'd be 3 point something. So that's what your calculator is doing every single time you're doing these questions, just so you know. So it's going to be 2 minus, the 2/3 can drop in front, log base 3 of x. Done. The next one, that z is to a half. So this is the same as saying log base 7 x5y over z to the half. So we're going to get log base 7 x to the 5 and then plus log base 7 of y and then technically minus log base 7 of z to the half. Now that's a straight line. I just ran out of room, right? I would just keep going as a straight line, straight line, straight line. And then I'm going to get log base 7 x to the 5 plus log base 7 y minus 1/2 log base 7z. And that would be the answer. The last one, we have log base 5 x to the half y. They're both multiplied, so we're just going to get a plus sign. So we're going to get log base 5 to the x to the half plus log base 5 of y. The half drops in front, so we're going to get 1/2 log base 5 of x plus log base 5 of y. Example 2 is just that example backwards. Example 2, you're going to have to be able to spot these. So when we look at example 2 and we go log base 6 at 8, log base 6 and log base 6 at, whenever you're going log base 6, log base 6, log base 6, that should scream, put me together. That's what it should scream. If it doesn't, it should. In your head, you should hear my little scream, put me together. That's what it should say. So if it's log base 6, log base 6, log base 6, you put them together. But the only way you can put them back together, you know how we pulled them apart? We pulled them apart and we put plus and minus 1s in front, correct? In order to put them together, we have to have plus or minus 1s in front. If we have something else in front, we have to raise it to the exponent before we can put them together. So in order to put together logs, you need plus or minus 1s and you need the same base. Okay? So, base 6, base 6, base 6, plus 1, minus 1. Do I have the stipulations that I need? Plus or minus 1s, same base. Check. I have all the stipulations I need in order to put them together. If they have plus 1s in front, they go in the numerator. If they have minus 1s in front, they go to the denominator. So this is going to become log base 6. 8 goes in the numerator. What else goes in the numerator? 9. What were they before? They were multiplied. So if you have more than one thing in the numerator and denominator, you multiply them. And then what goes in the denominator? The 2. So we can simplify this more. We go log base 6. And it's going to be 72 over 2, which is 36. Now, what does our calculator do when we do this? 6 to what power is 36? 6 to what exponent is 36? It's 2. So if you type log base 6 of 36 to your calculator, it's going to give you 2. We're going to skip B for a second here. We're going to look at C. What is the catch with C? There's stuff in brackets. How do we get rid of the brackets? Distribute the -1 in. So that's going to be our first step. We're going to get 2 log base 2 of 12 minus log base 2 of 6 minus 1/3 log base 2 of 27. So I'm saying log base 2, log base 2, log base 2. So it's screaming, put me together. However, that's the only, there's 2 stipulations in order to put together. It has to have plus or minus 1s in front, and it has to have the same base. Right now, there's not plus or minus 1s in front, correct? So how do I get rid of the problem? I have a 2 in front, and I have a 3rd in front. You bring it to the exponent. You don't take the sign, you just take the number. Because I'm allowed to have negative ones, right? I'm just not allowed to have 1/3. So, I'm going to take this 2 and I'm going to bring it up as the exponent. I'm going to take the 3rd and bring it up. I'm not going to take this negative sign with me. So I'm going to get log base 2 of 12 squared minus log base 2 of 6 minus log base 2 of 27 to the 3rd. Do you see how I did not take the sign? I just took the coefficient without the sign. Now do I have my stipulations? All base 2 plus or minus 1s in front. Yes. So once I have those 2 things, I can put them together. So I'm going to go log base 2. 12 squared is 144, and it's going to go in the numerator because there's a plus 1 in front. Where is this 6 going to go? Denominator, because there's a minus 1 in front. Where's this 27 to the 3rd going to go?
Down.
Denominator. 27 to the 3rd is actually 3, because it's the cube root of 27. So instead of 27 to the 3rd, I'm going to have a 3. So that 3 is going to go in my denominator, because there's 2 numbers down there. I'm going to multiply them. So I get log base 2 of 144 over 18. What do you get, 8?
Well, for your friends.
Yeah. So we're going to get log base 2 of 8. What's the answer to that without our calculator? It's 3. Because we say 2 to what power is 8? It's 3. So I'm going to have you work on E and F. Try these 2. And we're going to go through them. So, for E, do the 2 stipulations exist so that I can just do E? Yes. The 2 stipulations that exist are base 5, base 5, base 5. Now, some people said, well, what? Some people will say, what happens if they're not all base 5? Well, then you can only put the ones together that are base 5 and the other ones that aren't base 5 would just sit separately. You just wouldn't be able to write it all as one single logarithm, but you could write some of them together. Okay? So these have all base 5 and then plus 1, minus 1, minus 1. So we're going to get log base 5. 1,000 isn't going to be in the top because there's a plus 1 in front. 4 and 2 in the bottom, and I'm going to multiply. What's 1,000 divided by 8? 125. And then, what's 5 to what exponent is 125? 3. What's the problem with F? Base 3, base 3, base 3. So that's not my problem. You don't have 1s. You have to remember to move the 2, the half, and the nothing to the exponent. So I'm going to get log base 3 of, and make sure you have equal signs, guys. That's the worst thing that you have is you don't follow equal signs down, and it's an expression. This equals this equals this equals this. They all equal, right? And then minus log base 3 of 64 to the half plus log base 3 of 2. So I get log base 3 of 36 minus log base 3. What's 64 to the half? 8, because it's just the square root of 64. So it's an 8 plus log base 3 of 2, and then I'm going to put them together. So I'm going to get log base 3. The 36 is going to go in the numerator because there's a plus 1 in front. The 8 is going to go in the denominator because there's a minus 1 in front. And the 2 goes in the numerator because there's a plus 1 in front. So I'm going to get log base 3 of 72 over 8, which is log base 3 of 9, 3 to what power is 9? 2. So your homework that needs to be handed in for your Leppy Buck for Monday is the homework up till yesterday. Okay? We're going to get homework on this as we finish it on Monday. I intentionally did that because people need breaks. This is your long weekend break, so you shouldn't have to do math. The only way you're going to have to do math is if you didn't do it. If you didn't keep up this week, then that's on you. If you kept up this week, you have the whole weekend to not do math. You might have other homework, but not mine.